Hi, I am Antaryami and welcome to my channel. So in this video, I will explain the concept of survivorship curve and different life history classification or life history strategies. So let's start. So what is survivorship curve? A survivorship curve is a graph or a curve representing the number or proportion of individuals surviving to each age group for a given species or group. So this survivorship curve can be constructed for a given cohort based on its life table. Already I have been explained what is a life table in my previous videos. So a life table is particularly individuals roughly belonging to same age. Now, based on the studies of survival by a wide variety of organisms, population ecologists have proposed three different types of survivorship curve, that is type 1, type 2 and type 3. In this figure, we can see that the type 1 survivorship curve in which the juvenile survival is high and most of the mortality occurs among older individuals, that is after certain age. Whereas in type 2 survivorship curve, we can see that the mortality rate or the survivability rate remain equal or remain constant over the ages. Whereas in type 3 survivorship curve, so there is a high rate of death in juveniles and then much lower rates in the later ages of life. So if we compare the survivorship curve with the risk of mortality, then we can see that in type 1 survivorship curve, the risk of mortality is higher towards the end of the life stages, whereas in type 2 survivorship curve, the risk of mortality is remaining constant over the age, whereas in type 3, there is a higher risk of mortality at initial ages, whereas this is gradually decreases when the species grows. So, in type 1 survivorship curve, the mortality is concentrated towards the end of the maximum lifespan. For example, in the case of humans, that after 60 or 65 ages or after 70, most of the people are dying. Whereas in type 2 survivorship curve, a straight line signifying a constant mortality rate for from birth to maximum age. That is, in the case of rodents and reptiles, this kind of curve is obtained. In type 3 survivorship curve, there is extensively early mortality but high rate of subsequent survival, that is oyster, fishes and many invertebrates show this type of survivorship curve. Now, what is life history? So, the life history of a species is the pattern of survival and reproduction events typically for a member of the species. So, it reflects the pattern of survival and reproductive capacity. As we know, there are different kinds of animal throughout the ecosystem, and maybe they have, because of their certain physical attributes or physical characteristics, they have different rates of survival as well as reproduction events. So some of the central concept of life history includes offspring number versus size of offspring. That is, how many offspring the particular organism is going to produce and of which size. Then second factor is adult survival and reproductive allocation. So how this reproductive allocation is being related with the adult survival. So we will discuss it in details. Because all organisms have access to limited energy and other sources, there is a trade-off between the number and size of the offspring. Those that produce large numbers of offspring are constrained to produce fewer individuals, whereas those produce smaller offspring may produce in large in number. For example, in the case of lions or humans, and in case of fishes or invertebrates, we can see that fishes or invertebrates, they can produce enormous number of eggs, but these eggs are smaller in size, whereas in case of humans or in case of other mammals, larger mammals, the baby which is produced is larger in size. That's why it is smaller in number. So there is a trade-off between the size of the organism versus the number of individuals they produce. Similarly, when adult survival is lower, organisms begin reproduction at an early age and invest greater proportion of their energy into reproduction as compared to their growth. where the adult survival in higher organisms defer reproduction to a later age and allocate a smaller proportion of their resources to reproduction. Then, based on these characteristics or based on this life history, now the species are being classified into two different categories, that is R and K selected species. So, the great diversity of the life history can be classified on the basis of few population characteristics, which I already been explained in the previous slide. That is, such as fecundity or number of offspring produced, which is also known as clutch size, survival of the individuals, relative offspring size, and age at reproductive maturity. This principle applied to most taxa of plant and animal kingdom and were classified as R-selected species or K-selected species, which is based on the concept of MacArthur and Wilson 1967. If there is an unfavorable environmental condition, mortality becomes erratic and selection favors early reproduction and rapid development, which also involve high fecundity, short lifespan, small body size, high mobility, and high metabolic rate. These features become the characteristics of R-selected species. So, R-selected species particularly have shorter lifespan and smaller body size. If the environment is constant, selection favors slow development, low fecundity, longer lifespan, low or medium metabolic rate, longer body size, and so on. These features become the characteristic of K-selected species. So, these K-selected species particularly have longer body size or higher body size as compared to the R-selected species and having a longer lifespan. In such condition, R-selected species may exhibit a more or less J-shaped population growth and so type 3 survivorship curve. In contrast, these K-selected species, they exhibit more or less S-shaped growth and also show type 1 or type 2 survivorship curve. In this figure, we can see that these K-selected species, they show a S-shaped population growth curve, whereas the R-selected species, they show a J-shaped population growth curve. And they have different population attributes. For example, there is a high rate of intrinsic increase, that is Rmax, in R-selected species, whereas there is a low rate of increase in case of K-selected species. If we compare the competitive ability, then the competitive ability not strongly favored the R-selected species, whereas there is a high favor for the K-selected species because there is a higher rate of competition for the existence in the K-selected species. Now, the development is rapid in case of R-selected species, whereas slow in case of K-selected species. Reproduction shows at early age in the R-selected species, whereas reproduction occurs in the later stage in the K-selected species. The body size remains smaller for the R-selected species, whereas larger in the K-selected species. Now, the reproduction is similarity in the R-selected species, that is, they particularly give rise to birth at once throughout their lifetime, whereas heteroparity is followed by the K-selected species, that is, they can produce more than once throughout their lifetime. Now, the offspring size in the R-selected species are smaller, and in many that is small size with large number of offspring, whereas in K-selected species the offsprings are larger and few in number. So these are some of the characteristics of R-selected and K-selected species, and based on which we can differentiate the R and K-selected species. I hope this video will help you to understand the strategies of life history as well as to understand the difference between R-selected and K-selected species and different types of survivorship curve. For further informational videos related to ecological concept and other topics related to CSIR net preparation, like and subscribe my channel. Thank you.